Hello everybody, this is Nagendra and we are going to learn physics in this channel. Our channel name is Nagendra Science Class. In this channel, we are going to learn all the fundamentals starting from foundation and clearing the MCET, then mains and even in advance. Now, fundamentally, we are starting with the chapter motion in a straight line from foundation level. Now, what is motion? What is motion? What we say generally, motion is nothing but when any object is moving from one place to another place, whatever the direction, whatever the distance, if it is changing its place from one to another, we say that is in motion for that span of time. For example, if anything is moving continuously, we say it's in motion. Then, so motion is nothing but change of position. Change of position. And what is position here is nothing but where is it situated at a given time. For example, I am standing at one place. Maybe I am changing my place from one to another. Now the position is different. Now I am not moving anywhere. I am just standing here. Before I am standing here. That means from here to here, when I am moving for that span of time, I am in motion. And after that, I may be at rest. Yes, it is nothing but the motion is nothing but change of position. And coming to the motion, every motion is relative. For example, I am wearing the specs here. Now, wherever I turn, the specs are with me. With respect to me, the specs are not moving. Maybe for others, as I am moving, the specs are also moving. But for me, the specs are stable with me. If I turn up, it turns up. Turning down, moving up, moving down. Wherever I do, it turns that side. That means my position and specs position are always having the same distances at every point. Now this is called relativity. For example, now if a boy is moving on the road and he sees that a tree is going back, but the tree is there just as at every time, but he is moving. In next example, a boy is going to school in his school van and his friend is saying bye. Now the boy in the bus sees the boy on the road as he is moving backwards or he is going backwards. But due to what is the reason that the boy on the road is looking like he is going back? The only thing is this boy on the bus is going forward. At the same time, his friend who is sitting in the bus is not moving anywhere. They are just speaking together. Each other they are speaking. That means what? They are at rest. This is called relativity. Yes? So, no motion is absolute. Here, absolute is very important. Absolute means as it is. Wherever you go, that doesn't change. That is absolute. But here, we are saying that no motion is absolute. That means whatever the motion in the universe or the existence, it's not absolute. For example, in the bus, the driver is sitting in the forward or first seat and another boy is sitting in the next back seat and another boy is standing outside. A tree is there. This boy is at rest and bus is moving forward, and you know already that the tree is at rest. sorry. Now the bus is going with velocity v, whatever the speed, or it's moving forward direction. Now the bus driver sees the boy in the bus as he is at rest, because the boy is not moving, he's just sitting in the seat. And the driver sees the boy outside as it going backwards, because there is a relativity. At the same time, when the bus is going forward, the boy sees the tree as it is moving backwards. So within the bus, the driver and the boy doesn't move with respect to each other. That means with respect to each other, both are at rest. But the boy who is outside, he sees the bus is going forward, but to the boy who is in the bus doesn't move anywhere. But the wheels are moving, but bus is not moving. To him, the seats are just there, bus is not moving. But the other boy who is outside, seats are moving, bus is moving, everything is moving. This is called relativity. With respect to one, another is not moving. Here we have to introduce that set of frame or frame of reference. Frame of reference. What is this frame of reference? As the boy or the man standing outside and another man or the boy is going on a cycle. The man sees this boy is going forward direction, and as this boy is going on the forward direction, he experiences that the man is going out backward. The man is going as backward. Now we have to consider this man is having a set of frame. As per him, this boy is going right side, and for this boy, for his set of frame, the man is looking like he is going backwards. This is called relativity, and this set of frame, whatever we consider up, down, right, left, this frame is nothing but a reference frame. Now this is called relative motion. And now coming to distance. What is distance? For example, there are 2 points. I can make a circle connecting these two. I can make a circle connecting these two. Or I can make a parabola. Or I can make a, add them as a square. I can connect them. Or I can connect them as a arc. Whatever the path, I can connect like this, I can connect like this, I can connect like this. Whatever the shapes I can make all those here within the 2 points. Any number, we have infinity ways to connect 2 points. Maybe square, maybe parabola, maybe circle, or maybe anything here. We can connect 100 many ways, infinity ways. Now, whatever the path length, this is called the distance. This is called distance. For example, if I am taking 2 points, there is only one shortest distance between the 2 points AB. The only shortest distance, that is nothing but a straight line. A straight line is always the shortest, the minimum distance we can cover between the 2 points. We generally say perpendicular distance, or the shortest distance, nothing but displacement. This is displacement. There can be only one path for displacement, which is a straight line, the shortest distance or shortest path. But there will be infinite number of ways to draw or connect 2 points which are distances. Distance is nothing but the path length. The displacement is nothing but shortest distance. It's about distance and displacement. For example, now I am giving a particle moving. For example, a particle is moving in a circular path in anti-clockwise direction. Just like this, it's moving in anti-clockwise direction. For example, it started at point A. It goes through all the way and again comes to A. So what's the distance here totally? It's nothing but circumference. Circumference of the circle is nothing but the path of the particle. But what's the displacement? The shortest distance between initial and final points. It started here, gone through all the way, and again came to the same point. Now the distance between the point to point is 0, is nothing but displacement. But it gone through all the path. The distance is nothing but its circumference. Circumference 2 pi r is equal to circumference is nothing but distance. Another example, a particle is going like this, connecting half of the circle. Now from here to here, let us say it is r and r. And what is this? It's half of the circumference. It started here and gone in an anti-clockwise direction and reached a point B. Now it came from A to B. Now this path or path length is nothing but distance. And what's the path length here? It's half the circumference. And what can we say? 2 pi r by 2. It's half. So I can cancel here. I'm getting only pi r. And what's the displacement? Displacement is nothing but the shortest distance or shortest path. What is the shortest distance here? R plus r, nothing but a diameter, because it's at opposite direction, exactly opposite direction. So it's a half the circumference the path, and here the displacement is nothing but r plus r, which is 2r is nothing but d, the diameter. So this is the displacement and this is the distance. It's very, very important to understand as a fundamental. Now completing displacement and distance, we have to know about the velocity and speed. What is speed generally? What we say? For example, let us say first about velocity. Velocity. Yeah, what's velocity here? Is nothing but when a particle is moving in a straight line at time t equal to 0, as it is starting at point A, it is covering, let us say, 10 meters and reaching point B at t equal to 1 second. And at t equal to 2 seconds, it reached point C. At t equal to 3 seconds, it reached point D. And at t equal to 4 seconds, it reached point E. At t equal to 5 seconds, it reached F. and here everywhere it is 10 meters, 10 meters, 10 meters, 10 meters. Now in 1 second it cover 10 meters. In second also it covered 10 meters. In third also it covered 10 meters. In fourth and fifth, everywhere in every second it is covering 10 meters. Means same length. Means the rate of change of displacement. Why we are saying here displacement? Because it's a straight line. It's a straight line. That's why we say it's a displacement. Rate of change. What is this rate of change? What is rate of change generally? Means it is changing its path or its position in some factor. Means in 1 it is 10, into 2 into 10 is nothing but 20, in 3 into 10 is nothing but 30. Here what is the rate? The 10 is the rate. You know the interest rate also. If 2 rupees is for 100, it's nothing but 2% into 100 percentage. So 100 and 100 gets cancelled here. 2 is remaining, that's not but 2%. Like that, if for 100 it's 2, then for 1000 it will be 20. For 10,000, 200. For 1 lakh it is 2000. It's the percentage, the rate of interest. Like that, here also it is changing its position with respect to the time. In 1 second 10 meters, in 2 seconds it can cover 20 meters, in 3 seconds 30 meters, in 4 seconds 40 meters. Like that it is moving, it's changing its position with some rate. This rate is called as velocity. This rate of change of displacement is called as velocity. We just indicate with V. Now, if it is covering the same distances in same time intervals, here was the time interval. What is time interval first of all? Time interval is nothing but T2 minus T1. Generally we say what you have intermediate in interval break. Generally we say interval break. Here we are seeing nothing but time interval, nothing but you are getting some time span. Maybe it 1 second, maybe 2 seconds. For example, an object is moving started its motion at 2 o'clock. We are just counting at equal time intervals at first second, second second, third second, fourth second. Like that we are counting how much displacement happened. Or started at 2 o'clock. I'm just checking after 10 seconds, after 20 seconds, after 30 seconds, how it's moving. This is nothing but the time interval. Maybe 10 seconds, 10 seconds, 10 seconds, 5, 5, 5, 2, 2, 2, whatever it is. It is nothing but time interval. How can you get time interval? The initial time or the first final time minus initial time. The difference between these two is nothing but time interval. Now, if any body is changing its position with respect to the time, then we say that is velocity, the rate of change of displacement, its position. Then velocity V equal to displacement by time or d by t. You can write like that. If it's covering the same rate, or for example, if it is covering equal distances in equal time intervals, time t1 equal to, again here also t1, the distance I'm saying, the differences I'm saying here, t1, 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 or just t, the time interval is t. and from here t equal to 0, then t1, t2, t3 and t4 here, t5, t6, t7, t8, like that. With between any two intervals, the time span is nothing but t. The time interval is equal. In these equal time intervals, if it is covering same distances means if it is covering same displacement in equal time intervals, we say that the body is in uniform velocity. We say that the body is in uniform velocity. At the same time, we have to know about V average or average velocity. What is average velocity? You know, generally sum of the observers by number of observers. For example, if in 1 second its velocity is v1, then v2 is the velocity, then v3 is the velocity, then v4, like that. Sum of the velocities by number of velocities here, nothing but v1 plus v2 until vn divided by n is nothing but v average. This is called v average, nothing but average velocity. If v1 equal to v2, how it can be? The v1 is nothing but v equal to displacement by time. For example, in first second it is covering distance d1 and next second d2, and distance is same, time is same, nothing but d by t, because every time it is covering d and the time interval also same. So now v1 equal to d by t and v2 also d by t. Now v1 equal to v2, like that. If v1 equal to v2 equal to vn, nothing but I can substitute here in the place of vn, v1, v2, v3, v4, vn as single v, nothing but n terms are there. Then n into v by n is nothing but v. So v average is also equal to the velocity v when it is covering equal distances in equal time intervals, or same displacements or equal distances in equal time intervals. Then it is called as uniform motion, and in this case the average velocity is always absolutely equal to the velocity, because there is no change, there is no fluctuation on it. This is called velocity and average velocity. Now let us take 2 points here. And I'm connecting these 2 points like this, point A and point B. So a train started here, just going through this path and again coming and reaching the B, starting at A and reaching B. Now it is not covering the shortest distance, but it is going all over and coming back to B, coming to B. Now this is nothing but distance, it is not displacement. Displacement is this one, A to B directly a straight line. Displacement is this. What is distance? It's the path. This is the path length. This path length is called as distance, is nothing but distance. Now we are learning about speed. Now what we said before, the displacement by time, the rate of change of displacement is nothing but velocity. But if it is covering all the path, then it is called as length or the path length. it is called as distance. Now rate of change of distance here, the rate of change of distance is called speed. The rate of change of distance is called speed. How it's changing? The rate of change of distance is called speed. Now, for example, here also if it is covering same distances in same time intervals, then it is called as uniform speed. Why? Because it's covering the distance, the path length in same time intervals, same distances in same time intervals, then we say as speed, which is average speed. Now, so average speed average is equal to total path length by total time taken. The total path length by how much time it is taking. For example, it started 2 o'clock in the afternoon, 2 p.m. and it is ended at 6 p.m. 2 p.m. to 6 p.m. it traveled, and the path may be, let us say, as 100 kilometers it traveled from 2 to 6 p.m. Now, what is the time here? What we said, the time difference is nothing but t final minus t initial. What's the final time? Is 6 p.m. or 6 p.m. minus initial is nothing but 2 p.m. is nothing but 4 hours. 4 hours. And how much distance? The distance is equal to 100 kilometers, the total distance. And what we said, speed average equal to total path length by total time taken, or the total distance by total time taken. Now the speed average is equal to total distance is nothing but 100 kilometers, and the time taken is nothing but 4 hours, nothing but 4 ones, 4 25s. Now 25 kilometers per hour is nothing but speed average for this motion. This is called speed. And let us say, connecting these 2 points, a straight line is drawn, and this length we can say as the displacement, and we can say as an assumption we are taking as 70 kilometers because the path length is very less here. Let us take as 70 kilometers, and started here, gone all through the path and came to be in 4 hours. If you connect these two, it's 70 kilometers. Now the average velocity V average equal to total displacement, nothing but displacement is how much? 70 kilometers. Let us take as 72. So 72 kilometers here by 4 hours. The total time taken 4 hours is nothing but 4 ones and 3 is remaining here, 32. 4 is 32 kilometers per hour. This is average velocity for the 2 points, and this is average speed for the 2 points, the same points. Here for the same points, the average velocity is 18 kilometers per hour and the average speed is 25 kilometers per hour. There is a huge change between velocity and speed. Now we got about speed, nothing but average speed, but there is a lot of difference between velocity and average velocity. Velocity and average velocity. Here average velocity is nothing but total displacement by total time taken. here the displacement by time. And what's the difference between these two? For example, vehicle started at point A and ended with B. It's just going in a straight line. For example, straight line started in at 2 o'clock or 12 o'clock and ended its trip at 6 o'clock. Now, the time span is nothing but a t equal to 6 hours. The distance, let us say, as 100 kilometers. The distance here. But we did not discuss about the motion. We just said it's a straight line starting and ending points of time. Now we are saying that it started at A and slowly it raised its velocity and again slowed down because there's some traffic or signal. Again, after signal, it started its motion. Again, it's gone fast, and again some signal or bus stop came. Again started and again reached. Here in this section, for example, let us take an example of metro rail. Let us assume that for some part of it is a straight track. Now, between the 2 points of consideration, we have some stops. For example, let us say 4 stops are there. Now what happens when it starts? It slowly increases its velocity. When it is increasing its velocity from 0 it starts, so it increases. Now it reaches a peak of its velocity. Again it goes with the same constant velocity. Again there is a station. Now what happens? Again it slows down and comes to rest. Now passengers, some people will go out and some people comes in, and again it starts its journey. Again increases velocity, reaches some point, saturation point, again goes with this constant velocity. Again some station comes, again stops, again increases, again stops. Finally, but whatever the thing, it going in a straight line. It's going in a straight line. Then it's a straight line, means it's a displacement. And some time it took to reach from one point to another point. It's taking some time. And the rate of change of displacement is nothing but velocity. But here velocity is not constant. It's increasing, and sometimes it's constant, again decreasing, again increasing, constant, decreasing, increasing. All these fluctuations are happening. Now, what is its velocity? Is nothing but at particular time, whatever its velocity, we say there's a velocity at that point. And what's general velocity or average velocity? Nothing but total displacement by total time taken. That is average velocity. Now this velocity is also indicated as instantaneous velocity. It's average velocity and instantaneous velocity. Instantaneous velocity is nothing but what is the velocity at a given point of time, at a particular time. For example, at station v equal to 0. After starting at t equal to 1 second, maybe some v equal to 10 meters per second. After 5 seconds, maybe 50 meters per second. Yes, at that point what it is, that's instantaneous velocity, the time span. And here average velocity means that you're taking the whole span of time divided by the total displacement. Here let us think more about instantaneous velocity. Now when we say position, the position is nothing but where it is. It will be constant. I am standing here, my place or my position is constant. When we say time, it is not a constant. It's always increasing, it's always changing, it's always moving. So what is time here? Is nothing but t. Generally we are indicating, but what is t here? Is it 1 second? Is it 1 minute? Or is it 1 hour? Because 1 second we have again 100 milliseconds. Then microseconds, which is 10 power minus 6 seconds. We can make 10 lakhs of parts in 1 second. And in that also maybe we can go through it. So 1 hour is nothing but 60 minutes. 1 minute equal to 60 seconds. So what is time here? It's not a point. It's always a time span. It doesn't make a sense if you take a point of time. It is having some time span. Maybe 1 second, maybe 100 milliseconds, maybe 1 millisecond, maybe microsecond, whatever it is. It is always a span. Now, coming to general velocity or velocity average, generally we say the total or general displacement by time taken. Here time taken is very important. Maybe 1 minute, maybe 1 hour. This is the time taken, that span of time. Now this is equal to t. This is also equal to t, whatever the time. But if time t tends to 0 but not 0, reaching 0, maybe microsecond, 10 power 6th second means 1 by 1, 2, 3, 4, 5, 6 seconds. These many parts we have to make in a 1 second. Maybe 1 milliseconds, 1 by 100 seconds. Here 1 part of second or 100th part of second. Now it's not a point again. Here we say that t tends to 0 but not 0. That means it's a small span of time. Now see, displacement by time, where the time is tending to 0, then we say ds by dt. Here ds is nothing but shortest distance by time taken. Why it will be like that? V instantaneous. So V instantaneous equal to limit. We are limiting that t tends to 0. It's reaching 0 but not 0, which is a very less time span, and ds by dt. What is ds? The distance covered in small time dt, in small time interval dt. Now, if t is becoming small and small, for example, a particle is moving in a straight line with 100 meters per second. In 1 second it can cover 100 meters, and another second it can cover 100 meters. Now if I am taking milliseconds, means 1 by 100, I can make 100 parts of it. Now what happens? It will be 1 meter per second. Again, if I make micro, it's becoming even small. That means the displacement also becomes small. As you are making t lesser and lesser, then it always gives velocity at a particular point A, at a particular point B. At station, what is the velocity? In between the stations, what's the velocity? We can find average velocity. Velocity doesn't give any information about a fixed time and fixed velocity. At this point, what is the velocity? The average velocity that doesn't give any information, but instantaneous velocity can give that information. Average velocity can give the magnitude of our overall. It can give overall velocity, but it cannot give at particular point what's the velocity of the body. It cannot give. Only the instantaneous velocity can give that information. That's what all about instantaneous velocity. So what we can write here, V instantaneous is equal to limiting the time which is tending to 0, ds by dt. And same like that, instantaneous speed also the same thing. Speed instantaneous is equal to limit t tends to 0, the displacement ds by dt. Here you must see we have to go through it. Like, we have three types of motions. What? First one is linear, second one is rectilinear, next third one is curvilinear. Here we have the general term linear, linear, linear. You can see linear, linear, linear. Why? They are adding the rectilinear, curvilinear, linear. Because if you take a circular part, it's a circle, it's all curved. It's not having a straight line. But if you zoom it in, generally, if you take a small part, it's always a straight line. If you take any curve, if you take a small part of it, it's a straight line. Here also it's a straight line. Here also it's a straight line. That particular point is nothing but a straight line. So every motion is a combination of infinitesimal small linear motions. That's why we are adding linear, rectilinear, curvilinear. Linear is being added. Here also, when you take, for example, a particle is just going like this randomly. But if you observe, if you take the time span as t tends to 0, what happens now? It displaces, it changes its position. Now it's become a straight line. Now you can say that instantaneous speed equal to instantaneous velocity when the condition is t tends to 0. Now every displacement becomes, or every distance becomes straight line. The shortest distance, it becomes a displacement. Now the rate of change of displacement is nothing but velocity. Nothing but here instantaneous velocity. At that point, overall its speed, average speed or average velocity, whatever. But here it's instantaneous speed equal to instantaneous velocity. That's what we have to learn here. Now, coming to the vector. What is vector? Vector is nothing but any physical quantity that has magnitude and direction is called as vector. Coming to our chapter, motion in a straight line, we always describe in terms of displacement, velocity, acceleration, all these things. Now coming here, the vector is saying about point to point. If you add a straight line, it is showing that it is in this direction. And how much is the magnitude of length or the quantity of length? Let us say as 10 meters. This is magnitude. Let us say as east, west, north, south. So it's in east direction. So towards east, it's showing east from point A to point B. This east is nothing but direction, and this 10 is nothing but magnitude. It is having now 10 meters towards east. The train is moving towards east. The flight is moving towards east with some 100 kilometers per hour, with some 300 kilometers per hour. This 300 or 100 or 10, whatever it is nothing but magnitude. How much the quantity is nothing but magnitude. And east or west or south or north, whatever, x direction, y direction, up, down, all these are indicating the directions. So along with the direction, if magnitude is there, or along with the magnitude, if direction is there, with the combination of these two we call as vector. It is indicating the direction and magnitude, then that is called as a vector. Now coming to the vectors, I am seeing an example. For example, in India, a train is started at point A and ended with point B, going through C. Started going through C, ended with B. For example, if it is starting at Delhi and covering, let us say, Orissa, and finally reaching Hyderabad. Started at Delhi, covering Orissa, and ended with Hyderabad. The total displacement, the total distance here is nothing but the path length. Here, the distance is not having any particular direction, or not having, the distance is not having any particular direction, because it's not moving in a constant direction. It's always changing, coming back in all the directions. It's covering different directions. It's not having a constant direction. But if you connect A to B, it is having only single direction and some magnitude. Here we have, let us say, as a 2000 kilometers to cover all this. This is the magnitude, and there is no direction. Here it's covering, for example, let us say as 200 kilometers, and towards, let us say, south, towards south. Now 1200 kilometers towards south is nothing but vector, 2000 kilometers is nothing but distance, and it is not a vector. It's not a vector, it's only distance. So we can say any physical quantity that has magnitude and direction is called as vector. There is another definition to vector, nothing but speed with direction. Speed with direction is called as vector. Let us say vector. For example, from here to here it's having a constant direction, from here to here constant direction, from here to constant direction. If you divide the path, it's always constant direction. So speed with constant direction or with direction is called as vector. There are two definitions. What? Any physical quantity that has magnitude and direction is called vector. At the same time, speed with the direction is called as vector. These two definitions we can say for the vector. Now completing this one. Now this is Delhi, let us say this is Orissa, and this is Hyderabad. I can draw different vectors from point to point. From D to O, it's a vector, and O to H, it is a vector, and again D to H also is a vector. So I can make 1, 2, 3 vectors connecting 3 points. These are the 3 vectors, and 3 are having different directions, different magnitudes. Magnitudes are different, and the distance is also different, the directions also different. Now these are called different vectors. For example, let us say DO is equal to means Delhi to Orissa is equal to Orissa to Hyderabad. The displacements are equal. We cannot keep this. because vector indication is arrow mark. What is vector? The magnitude and direction. Here magnitude is equal, dO equal to OH, but it is going this direction, this is going this direction. Magnitudes are equal, but directions are different, so they are not equal vectors. V1 is not equal to V2. dO equal to OH in magnitudes, but dO vector is not equal to OH vector because magnitudes are same but the directions are not same here. So that's why this vector is not equal to this vector. Speeds may be equal, maybe here the magnitudes are equal but they are not equal vectors. When two vectors will be equal? When the magnitude and direction for both vectors are equal to each other absolutely, then these two vectors will be equal to each other. Otherwise, if only magnitudes are equal, they are not equal vectors. If only directions are equal, then also vectors are not equal. The condition is nothing but both magnitude and direction both must be equal, then only you can say vectors will be equal. Here the directions are different, so that's why they are not equal vectors. It's very important to remember. What's vector now? Any physical quantity that has magnitude and direction, that is called as vector. If not, what we call as scalar. So now the speed also is a scalar, the distance is a scalar. The distance doesn't need any particular direction, it goes any direction. It doesn't need any direction, it may go any direction. It is called as scalar. But the vector means from point to point, how much magnitude and what is the displacement, what is the direction, magnitude and direction, then it is called as vector. Otherwise it's called as scalar. That is what we have to remember. Thank you.